Hello everyone, Mr. Minnick is my name, math is my game, and you'll notice that the screen that I'm starting with in this lesson today is actually Desmos. It's a beautiful free graphing calculator, that's their claim to fame. And we've seen the parent absolute value function in this class in the last couple of days. But what I want to do is just use Desmos to go ahead and graph that. So here it is. This is the parent the parent absolute value function. A couple things we'll notice about it. See if I can bring attention to its vertex. Its vertex at the origin. It's going to go through the point 1, 1. It's going to go through the point 2, 2. It's going to go through the point 3, 3, 4, 4, etc. And what I don't like about Desmos is that Desmos doesn't put these little arrows, doesn't put these arrows on, but do be aware that the graph continues on that way forever. And moving into the second quadrant, the graph goes through -2, 2, -1, 1, etc. It's very imperative that everybody knows that graph, inside and out, forward and back, that without a graphing calculator, without looking at your notes, you can graph that. I'm going to go ahead and take a picture of that and paste it into these notes. Maybe. My computer with this casting thing, it's taken me some time to get used to. Mentioning the word cast kind of reminds me of the different art forms. I don't know if anybody's into magic or maybe even fortune telling. Did you guys hear about the little person, who was in prison? Basically they were fortune telling, and they got busted for fortune telling. And it was a little person, you know, like somebody that's like really short. And they escaped, and everybody was looking for them. There was a small, medium, at large. A small, medium, at large. Maybe that was a bad joke. Maybe I shouldn't have went there. Anyway, so this is the parent absolute value function. The parent absolute value function. The parent absolute value function. Okay, it's defined by y equals, or f of x equals, the absolute value of x. That's what it looks like. And you probably need to know that its vertex is at the origin. It goes through 1, 1, goes through 2, 2, goes through 3, 3, 4, 4, 5, 5, 6, 6. Couple things that we could say, a couple properties about this thing. It's V-shaped. It is V-shaped. It opens upward. It opens facing upward. That's another thing that you probably need to know about it. It opens upward. It's V-shaped. It's symmetric. It's symmetric. It is symmetric. And in this case, it's symmetric about the y-axis. It is symmetric about or around the y-axis. So the cool thing is I can trace over that graph. I'm going to kind of trace over this. So if I take that thing, if I take this graph, and let me just for effect, let me just see if I can add a little jagged edge to this left side. That way you could kind of tell the difference between the two. See if I can do this holding the microphone. All right, I had to collect both of those. Okay, so I'll group those together. So what I want to do, you see how that little jagged edge is on the left, everybody? So I'm going to flip this around. I'm going to flip this around from left to right. And you'll notice that the graph is symmetric. It's, you know, if I swap it around the y-axis, this graph still has the same shape. Okay, so it's symmetric about the y-axis. And one last thing I'll say about this one, is that its slope, and I'm not going to use the word slope exactly, I'm going to put it in air quotes. Actually, those are actual quotations, but I can't call it the slope, because slope only pertains to lines. And these aren't lines, they're rays, one of which is going upward, one of which is going downward. So I'm going to talk about the slope. And the slope of this thing is equal to 1, I'll say. The slope of this is equal to 1. Okay. So those are some things, they might be pretty obvious, but I want to point them out and I want to make them as clear as I possibly can. And there's 2 more things that we've talked about this year in chapter 2 that we need to mention about this thing. Let's think all the way back to chapter 2, section 1. When we talked about relations, we talked about all the possible x values. Anybody remember what that's called? All the possible x values was the domain. If we look at this graph, we know those arrows mean it goes forever. It goes forever to negative infinity along the x-axis and to positive infinity along the x-axis. So the domain of this goes from negative to positive infinity. On Friday's quiz, I'm going to ask you to graph one of these. I'm going to ask you to tell me what's its domain. What's its range? So the domain goes from negative to positive infinity, and the range does not. The range, it's true that the range does go all the way up to infinity, but the range, what's the lowest that the y values go? 0, nice, good. So the range of this goes from 0 to infinity, and we put a bracket on the 0. Okay. So what we're going to be doing today is we're going to be taking that parent function and we're going to be changing it. We're going to be modifying it. We're going to be applying all the things that we talked about on Monday and Tuesday, like transforming it by translating it vertically and or horizontally, or by reflecting it across the x-axis, or by vertically stretching it, or vertically compressing it. We're going to do all those things to these. You ready? Here we go. So the title, in case you missed it, it's 2.7 absolute value function graphs. Absolute value function graphs. Absolute value function graphs. I'm going to introduce a concept today. I've never used this language with it, but I'm going to call it relative graphing. I'll call it relative location graphing. It's a technique that I'm a firm believer in. You don't have to use it. There's certainly more than one way to the Eastwood Mall, but it works. It's awesome. It's really good stuff. Some of you might know that in my off time I enjoy target shooting. And if you've ever shot a rifle, maybe you've looked through a scope. And when you look through a scope, there's these crosshairs. Looks like it's called a reticle, I believe. And you'll see me use that. Matter of fact, I want to drag that over and put it in my everyday content, because I'm going to use that a lot. I'm going to use that a lot. Did it make it there? There it is. All right. So here we go. Example number 1. Graph y equals the absolute value of x and absolute value minus 4. There's more than one way to the Eastwood Mall. I'll show you 2 different ways you could graph this. One way you could graph this is the table method, and there's nothing wrong with the table method. The table method, what are you going to have to do? You're going to have to pick x's randomly. So you're going to have to randomly pick x's. Randomly pick x's. What do you want? Maybe negative 4, negative 3, negative 2, negative 1, 0. We're going to have to pick a whole bunch of them. This is what I don't like about this. 1, 2, 3, 4. You got to pick a whole bunch of them. I don't like picking points, but whatever. And then our y values are found by taking the absolute value of x and subtracting 4 from that. So let's see. If we plugged in negative 4, we'd have the absolute value of negative 4 minus 4. So that's going to be 4 minus 4, that's going to be 0. If we plugged in negative 3, we'd have the absolute value of negative 3, minus 3, so that's 3. Oh, minus 4, sorry, minus 4. So that's going to be 3 minus 4, that's negative 1. And then we're going to have the absolute value of negative 2 minus 4, so that's 2 minus 4, so that's negative 2. Absolute value of negative 1 minus 4, that's 1 minus 4, that's negative 3. Absolute value of 0 minus 4, that's 0 minus 4, that's minus 4. Absolute value of 1 minus 4, that's 1 minus 4, that's minus 3. Absolute value of 2 minus 4, that's 2 minus 4, that's negative 2. Absolute value of 3 minus 4 is 3 minus 4, which is negative 1. And the absolute value of 4 minus 4 is 4 minus 4, and that's 0. I don't know about you guys, but that's way more work than I ever want to do. That's too much work. But anyway, I told you I'd show you, so there it is. So I've got these points now that I could use to graph this thing. To be clear then, these points are negative 4, 0, negative 4, 0, negative 3, negative 1, negative 2, negative 2, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, negative 2, 3, negative 1, and 4, 0. Okay. I don't know how you feel about that, but I think that took a long time to do. And I'm still not done because I still got to connect those dots. So it looks like the lowest point on this graph, right there, looks like that's my vertex, that's my lowest point. That's going to be at 0, negative 4. And when I connect these, I want to make sure I get the right kind of thing going on here. They are arrays that extend out that way and that way. Now, if I take a good look at that, that looks familiar. What does that look like? To me, it looks like something we saw 7 minutes ago. What's it look just like? The absolute value parent function, doesn't it? So if we think about our parent absolute value function, our parent absolute value function, y equals the absolute value of x, we know that the parent function goes to the origin, 1, 1, 2, 2, 3, 3, 4, 4, negative 1, 1, negative 2, 2, negative 3, 3, 4, 4. So the parent function, the parent absolute value function, looks like this. Okay. So I'll group those together. So that's what the parent function looks like. Now, how does that green one compare to the parent function? How do they compare? It's just 4 units down. So if I know what the parent function looks like, and I know that what I'm going to be graphing is 4 units down, I could save myself a lot of time and a lot of energy, and basically, I don't need to go through that entire process if I understand relative location graphing. You kind of starting to see the forest for the trees here? See what I'm going for? Okay. So let's try example 2. Example 2, graph y equals the absolute value of x minus 3 and absolute value minus 5. So again, table method. Some people like it. I'm not a fan. X. My y's are going to be the absolute value of x minus 3 and then minus 5. So I'll probably pick negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. This is a lot of work. I don't like doing this, but whatever. So this is going to be the absolute value of negative 4 minus 3 minus 5. So that's 7 minus 5, which is 2. This is negative 3 minus 3 minus 5. That's 1. This is the absolute value of negative 2 minus 2 minus 5. So that's, did I do that right? 7 minus 5 is 2. 6 minus 5 is 1. Negative 4, negative 3, negative 2. Oh, I copied something wrong. That's my bad. Okay, so that's negative. That's 0. Okay. So then I get negative 1 minus 3 minus 5. So that's negative 1. And then I get the absolute value of 0 minus 3 minus 5. So that's negative 2. Then I get the absolute value of 1 minus 3 minus 5. So that's 2 minus 5. That's negative 3. And then I get the absolute value of 2 minus 3 minus 5. So that's 1 minus 5. That's negative 4. And then I get the absolute value of 3 minus 3 minus 5. So that's minus 5. This is a lot of work. Did you know it? Holy moly. This table method's a lot of work. So negative 4, 2. Negative 4, 2. Negative 4, 2. Negative 3, 1. Negative 3, 1. Negative 2, 0. Negative 1, negative 1. 0, negative 2. 1, negative 3. 2, negative 4. 3, negative 5. I don't even know what the minimum of this thing is yet. So far, I haven't seen the thing turn back around. I know it's going to be an absolute value. I know it's going to turn back around, but I don't even see it. And I just grabbed 8 points. Anyway, maybe we should try this. Maybe we should try this relative graphing thing. Maybe we should try that and see what that's all about. Maybe we should bring out this crosshair. I want to make this a color that pops. What's a nice color that pops on here? Red, 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 red. Okay, so there's a little bit of latency with my smart board and my finger when I'm recording, but does anybody understand what I mean by this relative graphing, where I'm going to need to move that thing to? Let's think back to yesterday. Yesterday we said that if you add something to the end of a function like we're doing here, that's going to do what to the function? Bonjour. Good day. It's going to translate it. Which way? Well, the minus 5 at the end. The minus 5 at the end. It's not going to be 5 right. It's going to be down. How many? Down 5. So that says, okay, we're going to take this crosshair and we're going to drag the crosshair down 5. Now let's look at the minus 3 in the parentheses. Je m'appelle Robert. My name is Robert. And my name is not Robert, but again, this is going to be a translation. Which way and how far? Well, we already got the down 5 established. So the x minus 3 in the parentheses, what's that tell us? Over 3. Which way? To the right or to the left? You might think it's to the left, but it's counterintuitive. To the right 3. Right 3. Okay, so now we've got these crosshairs located right there. Those crosshairs are kind of like our new home. No reference to Wyndham intended. Those crosshairs are where our vertex is going to be. It's as if we're graphing the parent function from those crosshairs. So now we get to be like Kazoo Kid. I like to have fun. I like to sing, dance, pretend. I'm going to pretend now that I'm graphing y equals the absolute value of x, and that this is my origin. You picking up what I'm putting down here? So what do I know about my parent function? It goes through 0, 0, and 1, 1, and negative 1, 1, and 2, 2, and negative 2, 2, and 3, 3, and negative 3. Oh my gosh, dude, that would have been like so much faster if we could have just graphed it like that right from the beginning. That would have saved so much time. That would have been way easier. Are you picking up what I'm putting down here? Is it making a little bit of sense? You think you could graph one of these on Friday's quiz? You're going to have to. No graphing calculator. No graphing calculator. Now, I know somebody out there doesn't believe me, so let's go ahead and look at it on Desmos. Absolute value of x, minus 3, and then minus 5 at the end. There it is. There it is. How's that compared to what we did? It's 3 right, it's 5 down. I think we did pretty good, huh? Are there any questions about example 1 or about example 2 or about this relative graphing? Okay. Let's look at example 3 then. Example 3, let's try to graph y equals negative the absolute value of x plus 4 and absolute value plus 7. I'm going to need my crosshairs. Going to need my graph paper. I'll send this to the back. Order, send to back. And I want to make my crosshairs maybe translucent a little bit. There we go. I'll lock this in place. So where are my crosshairs going to go? 7 up, and so this plus 7 at the end tells me up 7. And then what? You'd think right 4, but the right left is the opposite of what you'd think. So it's left 4. So up 7 and left 4. So my crosshairs are right there. So what that means is that the vertex of my graph is going to be at the point negative 4, 7. That's going to be the highest or lowest point. Now, let's take a good look at that. There's another element introduced here, isn't there? There's that negative in front of the absolute value. This function, the y values are defined by the absolute value of x, and we've said, let's make those the opposite of what they used to be. Normally, absolute value functions open upward. What's this one going to do? It's going to open downward, right? So that negative right in there, means that we're going to have a downward opening absolute value function. But we can still do this relative graphing. We just got to realize, well, we know our vertex is going to be right here. It's just like the parent function, but instead of opening upward, it's going to open downward. Well, the parent function, we go over 1 and up 1 and over 1 and up 1 and over 2 and up 2 and up over 2 and up 2. But we're not doing that. We're going to be opening downward, so we got to move these. Well, I'll just get these out of the way. So from right here, I'm going to be going over 1 and down 1, and 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 I'm going to continue that, right? So now, let me go ahead and fill those in. I'll make them red, 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 red. Okay, like that. And like that. Okay. What do you think about that? Is it that bad? Maybe when you first see it, first couple times, you're going to be like, dude, I don't remember anything from class. And I get it. Believe me, I know what happens. You have class at 9 o'clock in the morning. And then what? Then you go to 4 other classes and you eat lunch. And then you get this news about something that happened at home. And then you go home, and then you watch Dr. Phil for an hour because it's a pretty good show. And Dr. Phil has a cool voice. And I like the part at the end when him and his wife walk out holding hands. I think that's the cutest thing. And then you're like, oh, Ellen's on, so I'm going to watch Ellen too. And you watch Ellen. And then it's dinner time, and you eat dinner. And then you're like, oh, I got to call my friend. Well, I got to Nobody calls anybody nowadays. I got to FaceTime my friend. So you FaceTime your friend or Snapchat or whatever. The next thing you know, it's 9 o'clock and you didn't do your homework. You're like, I'll just do it tomorrow morning. So then on the bus, you dig that out and you're looking at it and you're like, dude, this doesn't make any sense. I get it. I understand. Believe me, I understand. But anyway, this video is going to be up on YouTube. Shout out to everybody watching it on YouTube. Any questions about this relative graphing before we try a tough one? Before we move on, we better talk about the domain. The domain of everything we graph from now until chapter 6 is going to be negative to positive infinity, just about. Just about all the domains of everything we're going to graph this year is going to be negative to positive infinity. I would be ultra impressed. Now, when I say ultra, I mean very. I would be super, duper, uber impressed if somebody could give me the range for this the right way using interval notation. Everybody always misses this. What do you got? Okay. Good try. Not to 0, not to 0. Negative infinity all the way up to 7. There it is. Negative infinity all the way up to 7. That's our range. Okay. So what we're going to do now is try one that's a bit more challenging. But not that much more challenging. Example 4, we're going to graph y equals the absolute value of 3x. I think what people don't understand about math sometimes is what all the different things tell you. When I look at that, I'm scanning it and I'm looking for numbers. I'm looking for operations. I'm looking for things being added inside the parentheses, and there's nothing. I'm looking for things being added outside the parentheses. In this case, the parentheses, when I say parentheses, I mean absolute value bars. And there's nothing being added at the end. So if I think about my crosshairs on this one, if I think about my crosshairs, are my crosshairs going to be moved at all or translated at all from where? No. So my vertex is still going to be at the origin. My vertex on this one's still going to be at the origin. If I'm scanning this, I'm looking for a negative sign in front of anything. I don't see a negative sign, which means it's still going to be an absolute value function or a V-shaped thing that opens up, right? There's only one thing that changed, that 3. And that 3 tells me all my y values will be 3 times as large. What I mean by that is in the past, let me see if I could get a crayon here. I like this crayon. Crayon, there we go. So in the past, I would have gone over 1 and up 1, and over 2 and up 2, and over 3 and up 3, right? But that was in the past. This one says all my y values are going to be 3 times as high. All my y values are going to be 3 times as high. So when I look at this point in particular, this point would have been the point 1, 1. But what happens is I'm tripling that 1. So that's really going to be the point 1, 3. Does that make sense? Okay. Where people get these twisted is they want to, instead of going over 1, they want to go over 3. No, I'm not going over 3. I'm still going to go over 1 at a time. And I'm going over 1 more at a time, and 1 more at a time. But my y values are increasing in triplicate. Okay? So if I look at, let's say, this point right here, that's the point 2, 2. That's the point 2, 2. But again, what's happening is that y value gets tripled. So I don't go through the point 2, 2. I go through the point 2, 2, 6. And then I can get the other one by symmetry. Does it make a little bit of sense? So what about that next one then? It's going to be 3 what? 3, 9. And so when I graph this, It's going to look narrower. The graph will be higher. It's called a vertical stretch by a factor of 3. Vertical stretch by a factor of 3. Now, since these things are kind of like lines, I can talk about using air quotes. I could talk about my slope if I wanted. Instead of having to multiply all those things, I could talk about my air quote slope. And my slope is 3. So you know what slope means, right? Slope means rise over run. So that's like 3 over 1. So that means I could rise 3 and go over 1, and rise 3 and go over 1. And does that make a little bit of sense? Cool. So if I'm being honest with you, graphing these absolute value functions using relative graphing, using all the things we talked about the last 2 days, they're really not that bad. They're really not that bad to graph. Let's try 2 more. Example 5. Graph y equals 3/5 times the absolute value of x minus 1 and the absolute value minus 4. And I know you're thinking, dude, the fractions, oh no, fractions, oh, I'm scared. Fractions aren't that bad, believe me. Fractions aren't that bad. Got my crosshairs going. Hopefully we're starting to get the feel for this thing. Where's my crosshairs going to go? Which way? Down 4 and then and right 1. So I'm going to be like Kazuki and I'm going to pretend that's my new home. One thing I didn't point out earlier, once I establish where my crosshairs are, it's as if I can kind of forget about these other things. And now I'm just looking at y equals 3/5 times the absolute value of x. I'm just going to graph that. I'm just going to graph that from right there. I'm going to graph that from right there. So here's my vertex. There's my vertex. I guess my vertex in the coordinate plane, the vertex happens at 1, -3 if I needed to label that. But so we're graphing a relative of a line. In lines, you only need 2 points to make a line, right? Or a ray. So the only other thing then that I need to look at that's going to help me figure this out is this 3/5. That 3/5 is my slope. My air quote slope. That's 3 over 5. That's rise 3, run 5. That's rise 3, run 5. Not rise pies. 1, 2, 3, 1, 2, 3, 4, 5. So it's going to be that point right there. Rise 3, 1, 2, 3, run 5. 1, 2, 3, 4, 5. That's going to be that point right there. Whoop, right there. I'm using champion colors. Sorry. So when I graph this one, it's going to look like that. And it's going to look like that. What do you think? Not bad? Okay. We could stop there today, but I fear that if you see one like this, you're going to be last. That one's not in the form we've been looking at. That one's not in the form we've been looking at. Oh, man. It's in the wrong form. So maybe we should write y equals, well, what would go first? What would go first? Whatever you want. Well, we had been putting the absolute value term first. Our absolute value term is this, right? So the first thing would be the negative absolute value of -4 plus x. Oh, man. Now what goes at the end? +1? Okay. Oh, man. Would it offend anybody if I... No, I better not. I better not. Okay. So, Can I switch these two things around? The commutator property lets me do that, right? Okay. So what I've really got is y equals negative the absolute value of x. Is it plus 4 or minus 4? Would it be minus 4? And then plus 1? Now we could probably graph it, right? Okay. On tomorrow, there's some ones that are even trickier than this. I don't want to confuse you. Well, now that we got this relative graphing down, I could show you some way more advanced ones. I don't want to push the issue too much. But how do we feel about being able to rewrite that in the right form? Okay. Like if you run into one of those, you might have a shot at it. Okay. I'd like to give a shout out to the future Mr. Minnick. He's an awesome guy. I'd like to give a shout out to my second period class. They're an awesome class. And in my fifth period class, they've actually been holding it down really well lately. I'll give them a shout out as well. See you next time. Good.